All right, we have reached our last topic of this scale or this module. We're going to be talking about solving inequalities including absolute values. So notice everything up to this unit, we've been working on one thing at a time. First, we worked on equations. Then we worked on inequalities. Then we worked on absolute values. This is combining two of those things. We're going to look at inequalities that have absolute values in them. So 2.0 that we are using is graph inequalities, including compound inequalities, and check the solutions. We've already touched on this, but we're going to use it again. And then the 3.0, I want you to pay special attention to. Solve equations and inequalities, including those that involve absolute value. We have already done this several times now, but we are reaching the end of our scale. We're using this in a different way. This time, we are combining these two things. We're actually going to learn how to solve inequalities that involve absolute values. So that's what part we're working on today. We have returned to this 3.0 3 times now. All right, a little bit of review. We need to know what an and or an or inequality is. So this is from previous lessons. Remember, if it's an and inequality, and you're looking at a number line, it's going to be shaded in between. That means the solution set can fit both inequalities at the same time. So if I wanted to write this inequality out, x has to be greater than 5, and notice I did not put the line under that. It has an open circle here, so that just means greater than. X has to be greater than 5 because it's shaded this way. But x also has to be less than 9 because it's shaded this way as well. So that would be an and inequality. And you can also think of it as a number can fit both of these things, both of these things at the same time. So if you pick a number, let's say 7. 7 is greater than 5, but less than 9 at the same time. Now an or inequality is shaded not in the middle, but outside. One's pointing left, one's pointed right. So if we wanted to do this inequality, it would be two separate things. It cannot be both at the same time. It's either one or the other. So the first one is x is less than 5. Notice the open circle again. The next one is x is greater than or equal to, because it has that closed circle, 9. So notice you cannot pick one number that fits both of these at the same time. That's why it's an or. So like take 4. We can take any number, 4. 4 is less than 5, but 4 is not greater than 9. So that one only fits one of them. You can pick another number, let's say 8. 8 doesn't fit either one. And then we can pick something on like the right side. Let's say 10. 10 is greater than 9, but it's not less than 5. So that's why that's an or. You cannot pick a number that satisfies both of these. It's either one or the other, or neither of them. All right, absolute value inequalities. This is an inequality that contains an absolute value expression. Okay, so if you remember, we just solved absolute value equations. When you have an absolute value, since the answer is always positive, you kind of had two different solutions, okay? You had to take the absolute value and isolate it first. Then you set it equal to the positive version, and then you set it equal to the negative version. There were kind of two different answers. The inequalities are very similar, okay? Step 1 is to always isolate the absolute value expression. Step 2, once you have the absolute value expression isolated, you're going to split the inequality into two inequalities without the absolute value symbol. So this is where you kind of split it off, just like we did with the equations. The first inequality, you are going to keep the inequality the same. Everything kind of stays the same in the first one, except you drop the absolute value symbols. In the second inequality, you are going to flip the inequality sign and multiply the other side by -1. Or in other words, you're going to negate it, change the sign. You're going to change the inequality sign by flipping it and change the sign either from positive to negative or negative to positive on the other side. So let's try some basic ones first. We have the absolute value of x is greater than 5. Since it's an absolute value, that's always positive. That means whatever's inside of there could have been positive or negative. So we have two different options. So the first inequality, you're going to keep the inequality the same. Just drop the absolute value. So x is greater than 5. The second inequality, read part B, flip the inequality sign and multiply the other side by -1. If you take 5 times -1, you get -5. Or in other words, you negate that side. So there's our two answers. So let's figure out if this is an and inequality or an or inequality, because we have two different inequalities here. So it does want us to graph this one. So let's just sketch a quick graph. I'm just going to put my two numbers that I have. Here's -5. Here's 5. Remember, you always want to put smallest number on the left, greatest number on the right. That's how the number line goes. And then let's shade. The first one says x is greater than 5. So I want to shade everything greater than 5. Open circle. This would be greater than 5. Second one, x is less than -5. Open circle. This way. So as you can see, this is an or. Or you could just test numbers. Think about this. Pick any number. Let's say I have x is greater than 5. So 6. 6 is greater than 5. So that works. But 6 is not less than -5. So it cannot fit both of these at the same time. So it's an or, not an and. All right, let's do this one now. Same thing. It's already isolated. The absolute values have nothing else around them. So we're going to keep one of them the same. And then for the second inequality, we flip the sign and then negate the side that does not have the absolute value. And then we solve. -4, x is less than or equal to 2. Same thing over here. X is greater than or equal to -10. So let's think about if it's an and or an or. Can you pick a number less than 2 that also fits the other inequality? Okay. So a number less than 2, let's say 1. Is 1 greater than -10? Yes, it is. So that means this is an and. And we'll see that on the graph as well. So we have -10 over here. Remember, smallest number goes on the left, greatest number goes on the right on the number line. We want x to be greater than or equal to 10. So it means I'm going to shade this way. But we want x to be less than or equal to 2. So notice I'm using closed circles. And there's your shading. You would shade in between. So that means I could write this one this way as well. X has to be between, whoops, let's do it down here. X has to be between -10 and 2. All right, I don't want this video to get too long, so I'm gonna pause it right here, and we'll just do two parts. So I'll do part 2 on the back page. Make sure you watch both videos.